Hey guys, welcome to my channel. In this channel, I'm basically gonna go over basic concepts for circuits. In other words, I'm just gonna go over the Circuits 1 course. So, if you guys are in electrical, mechatronics, and I think computer, this course code for you it's ECE 2205. If you're in other disciplines, it might have other codes, but it's basically the same concepts. It narrows down to sort of the same thing. So, I'm not saying you guys should skip class and rely on these videos. You should definitely go to class. But if you're screwed and you have a midterm coming up or an assignment and you're like, oh shit, I should have went to class, I guess you'll find these videos sort of helpful, especially because I just took this course last year, and I still remember the struggles that I had with this course and what I wish my prof did, and I hope I can make it sort of simple for you guys. So basically, there are three fundamental laws that you should have embedded in your brain, so they should become sort of like second nature for you. No matter how complicated a circuit gets, you're still gonna use at least two of these three laws or rules. So the first one, it's Kirchhoff's current law. So as you guys saw before, in physics, if you remember, the law of conservation of energy. So the energy going in the system is equals to the energy going out of the system. It's sort of the same thing, and I'm gonna try to make you guys understand it as much as I can. So if you have a node, which is basically where more than two wires meet, so these are three electrical wires. So if you have a node and then there's a current I1 that's going this way into the node A, and I have currents I2 and I3 coming out of that node, then Kirchhoff's current law states that the total current I going in equals the total current going out. So I can write that I1 equals to I2 plus I3. Or it can be the other way around. It's not always in this way. I can have I2 also going into the node. So I can have, in this case, I can have I1 plus I2 equals I3. So it's not always you have one current in or one current out. It just depends. And there isn't really a rule that you should stick to, that you should always assume that there's only one current going in or two going out. You can assume that all three currents are going in, that I1 plus I2 plus I3 equals 0. And I know this doesn't make sense to you, but when you solve for these currents, you're going to get a negative value for one or two of them, which basically means that one of them flows in the opposite direction. So if I have this combination and I assumed that all currents are going in, to you it doesn't make any sense, because like something has to come out but nothing's coming out. So if you assume that these directions for the currents, and then you come up with your equation that I1 plus I2 plus I3 equals 0, you're going to solve it, and eventually, let's say you get I1 equals 5 amps, I2 equals 3 amps, and I3 equals negative 8 amps. So what this means is that you assumed the direction for I3 wrong, because there is a negative sign here. So the actual directions are I1 and I2. Since they're positive, then you assume them right. And then you have I3 opposite to what you assumed before. So don't be afraid to take assumptions and don't really put in too much thought into your assumptions before you solve. Everything, if you just stay consistent, everything is gonna come out nice and easy, and you're gonna get the right answer. So don't give it too much thought. Now the second law is KVL, and this is Kirchhoff's voltage law. So this basically states that the total voltage around a loop is equal to 0. And for you to really understand how this law makes sense, you need to know the meaning of voltage. Voltage, another name for it, is potential difference. In other words, voltage AB, it means the voltage at point A minus the voltage at point B. So that's why it's called potential difference, because we always have a minus sign here. Voltage is basically we measure the voltage between 2 points and we subtract them. That's what we're interested in. That's what they asked. That's what you're going to be asked in the exam, to find the voltage drop across a resistor, let's say. So a voltage drop across a resistor, this is point A and this is point B, it's going to be VAB, which, as I mentioned before, is VA minus VB. So the way this makes sense is that, let's assume that we have a circuit. Here we have a bunch of resistors and a light bulb. This is a battery source, so this is a 5 ohm resistor, this is 10 ohms, this is 5 volts, and this is a light bulb. So let's say we have point A right here. This is node A. So if we go around this loop and we go from point A and come back, we make one full turn and we start at A and come back at A, according to Kirchhoff's current law, it's going to give me a 0. This is what this sign means. It's a full loop. It's a full revolution. So let's just write it mathematically. Let's say I don't really know his law. I'm gonna write down the equation for going around a loop, one full revolution. So I'm starting at VA. So the starting point is A and the end point is A. So this translates to VA minus VA, which equals 0. So this in some way proves the logic behind Kirchhoff's voltage law. And the third and final law that we're going to talk about in this video is Ohm's law. And I'm pretty sure you guys are familiar with it. And basically, it's the famous equation V equals IR. And just to put it into some sort of a circuit schematic right here, if you have a resistor and this resistor has a resistance of R ohms and there's a current going down the resistor at I, again, I'm going to assume that this is the positive terminal or the positive part and this is the negative part. Why? Because current is flowing down. It flows from the positive all the way down to the negative. So that's just the sign convention that I've stuck to for about 2 years. I always assume that if I'm gonna assume the direction of the current, and then where the current is coming from is the positive, and where it goes to is the negative part. So if you have a resistor and the resistance of the resistor is R ohms and the current passing through it is I amps, then the voltage drop across the resistor is I times R. So basically these are the 3 laws that you guys should just try your best to understand them. Don't just memorize them, because the logic behind them is really important too. If you understand the logic behind them, you kind of get the way of thinking or the logic behind solving, analyzing circuits. I hope you guys found this video helpful, and just let me know if you have any questions. I'm going to have the link to my Facebook in the description. So if you guys have any questions,